Is the global behavior of the derivative, and we will more and more and more and more this coming year, that's for sure. But we've studied the derivative at a point. We said on the warm-up, like, we really care about this, f prime of 3 equals 6. But what we haven't really thought very much about, which I'd like us to turn our attention to today, is like what in general is the behavior of the function that represents the derivative itself. So let's take a look at the one from the warm-up here as our example. And we've already seen, you saw, thanks students for coming up and doing it, 2x is like the general function that represents the derivative. So we have the following values, including the one that we calculated in the warm-up, 3, 6 on the derivative. Like I said, already you're thinking, I haven't really thought about this yet, this idea that the derivative has a set of points that lie on it, that like satisfy it. Like it's its own function too, you guys, and maybe it's worthy of study. So it goes without saying that this table is what emerges, and that those in the right column are the slopes on the original function at various values. So what does the graph of f prime look like? Well, maybe that goes without saying, but let's just kind of try to think about it carefully and what this would mean. What shape does it have, obviously? Yeah, and I think you could graph 2x without my help too. Yeah, it's a line, but there it is in blue, f prime of x. There's a lot of already to note here, isn't there? Notice that you could say, we could start having the same kind of discussions that we have normally about f prime, couldn't we? Like we could say f prime is increasing. Are you comfortable with saying that? That the slope is increasing as you go from left to right on the original function f. Does that reckon with you, right? As you move from left to right on the parabola, is the slope increasing the whole time? It is actually. Even on the left side, it's increasing, isn't it? Isn't this what it looks like for slope to increase on negative slope? Because it is actually increasing. It's like going from -5, the slope of like -5 to -4, -3, -3, -1, 0. That is the slope increasing. Even on the left side, it's always, as we go from left to right, increasing. That's what this graph shows. It should make sense. What else do we see? We see that, is it obvious from this graph where slopes on the original graph are negative and where they're positive? When is f prime outputting a negative number? When, yeah, to the left of 0, right? And to the right of 0, it outputs positive numbers. You're starting to see how, even though this just looks like a line, you're like, oh wait, actually it does communicate a lot about f. It tells you that f, the original function f, has negative slopes and then positive slopes. Lots of interesting information on this graph, actually. So, I have that marked on here. I guess I forgot to have this. I'll just put this up real quick here. Yeah. So here's the original function down here. I just want to like emphasize the connection between these two, right? That's what we were just talking about. Negative slopes over here, positive slopes over here. Sorry, I'll leave that there for a second. I think there's a question like that in the packet too, one of the packets or something, where it asks you, no, it was the homework, the one that says intro to chapter 3, where it asks you about the slopes increasing. Wasn't there a graph that said something like that, had a couple points marked on it, and it asked you to talk about the slopes themselves increasing. That's kind of crazy to think about, like the rate of change of the rate of change, right? But we do that all the time in life too, not just in calculus class. Anyway, lots of pretty pictures here. Any thoughts that you want to add to the mix? Anyone from the floor? Good. Blowing anyone's mind today, I don't think yet. We'll try. We'll always try. All right. Well, here's a task for you to try. Here's a graph of a function f, just to be clear on the task, and now we're graphing the derivative. So I'd like you to give that a try. I mean, you can, if you'd like, you can know that that's y equals x cubed, but already I'd like you to think about what it would look like, and why though. Can you actually like plot some points maybe? Actually think about what the slopes would be. I intentionally didn't write y equals x cubed up there because I don't really want you to think algebraically about this. You're welcome to do the whole definition of the derivative and get the actual result. But why should it appear the way it does? I have another one down here for anyone who's bored by the first one. This time we're going the other way. This time we're going the other way.
Oh, that is the derivative.
This is the derivative. Some good conversation. All right. The first graph. Let's hear from maybe from Cedric and your table up here. What did you guys come up with? What do you think? Again, just kind of on a visual, intuitive level. What do you think it should look like and why? Okay. Let's listen to the reasoning too on this. So why? I think we all agree. I heard lots of people say parabola. So what's the intuition there?
So the right side of the graph, of the original graph,
Thanks, Ken.
looks like the first parabola from the warm-up.
Okay.
So you can imagine that would look the same. And then like this is inverted on the left side. So then for the f prime, when it was like this, it was a straight line. So just like flip it, so it's above the x-axis.
Okay. Okay. Yeah, I think it's parabolic. Do you want to add your voice, anyone? I mean, you're welcome to say something similar.
The absolute value function.
Yeah, I guess that's an interesting question. The manner in which I think, so it actually is, what Ashley's saying is, I guess, she agrees with you that the slopes are always positive or zero on this graph. And that they decrease as you tend towards zero, and that they increase after zero. But why do we think it's a nonlinear style increase or decrease? I don't know. We need some help. Do you hear her criticism? We know it kind of looks like this, but why not this? Like, it's a really kind of deep assertion to say the manner in which it's increasing or decreasing. Alex.
The slope starts out really high, but then it continues to decrease as it reaches zero, so it has to be a parabola.
Okay. Okay. Say it your way, John. Go ahead.
I was going to say that, like, in order to get like that sort of straight line, now that I'm thinking about it, it doesn't work the entire way, but I imagine it would be something like 2 to the x, because then like the slope changes by 2. No, not by 2. It will change by that. I might be wrong.
Julie?
I don't want to get into like the algebraic thing.
Well, maybe I'll give you permission. Here's a pass. There you go.
Take a derivative, like we did the x squared minus 6, it turned into like a linear function. So like I'm thinking, if you have a cubic function, you'll be able to represent a quadratic or something from one level below, because you're like analyzing the rate of change of the rate of change. So it's like the rate of change times x. So
Yeah. Okay. I think that's fair. Bringing the algebraic piece a little bit there. Anyone else have something to say about that? Okay. I mean, we'll graph a little parabola here in a second. The only other criticism I would have in an absolute value graph is, what do you say about the slopes as you go from go across zero? You're saying that the slopes abruptly change, don't they? Like on a dime, and doesn't seem to be what's happening in the picture. Yeah, I don't know. So. Yeah, lots of good reasoning though that you guys shared. Certainly we can graph one slope. It looks like the slope at the origin is 0, and actually I think we've run through that math before, so we know that point's on there. But then on the right and left we have positive values, don't we? So if we wanted to be really precise, if all we had is a picture, we might do a whole bunch of tangent line drawing activities, right? And calculate a whole bunch of slopes and start plotting them. But I don't know. Maybe we could find one at least. What do you think? What do you think the slope is at 1, 1? I don't know. The slope there, you think? I don't know how you would know except to like draw it very, very carefully or actually run through the computation. But yeah, it happens to be 3 actually. But anyway, you wouldn't necessarily know that. I just, yeah. If you run the calculations, I'll just tell you that is what you get. Okay. Right? You guys do. Thank you. All right. All right. What about this one? Any interesting discussions here? Piper wants in on this one.
It would be an absolute value function because the slope when x is -1 and the slope when x is positive, is positive 1.
Okay.
So that just.
Yeah, there's a lot to like about what you just said. This one we do have like an abrupt change in the slope graph here, so kind of makes sense. Okay, yeah. Yeah.
Isn't the slope just 0 for both?
This is f prime. We're graphing at.
Oh, that.
Yeah. Let's keep adding to the conversation. Is this an absolute value graph we're being told? Okay, go ahead, Corinne.
On the right, it looks like the slope is 2, so it's
So you get to keep it. Yeah, did you notice what Corinne noticed? Is that if you're at least in the front row of this classroom, maybe you see that the slope on the right is actually 2, so it's not exactly an absolute value graph. I don't know.
It's like a check mark.
It's like a check mark or something maybe. So I think that's fair. So something like this, but over here it's like steeper. That makes you uncomfortable? I meant to have it go up, left 1 up 2, right 1 up 2, right 1 up 2 on this side, and left 1 up 1, left 1 up 1 on the left side, something like that. There is actually a what's up?
So there does that mean there's like a dot in the middle of 0? Or wait, no, never mind, I'm just being dumb. Okay.
Well, no, you're not being dumb. Actually, I'd like to ask about this. What's going on here? What's going on here? Yeah, with the dot at 0. I mean, I took the liberty of defining it there, but was that a right thing to do? Criticize me. Feel free. Yeah, Piper.
Well, there's no way to define the slope at 0 for this one because it's an abrupt change in slope, which is the same reason that when we put when it asks what the domain of when it's increasing and decreasing is, we never use a closed bracket. We always do a parenthesis when there's an abrupt change.
Yeah, we have still a love-hate relationship with that a little bit. You're right. We haven't fully had that conversation. It does feel a little weird to talk about the slope at 0. Am I at least okay? What do you think? Would you mark me wrong, though? I mean, is the picture of this derivative this?
Yes.
Yes.
Could there be other answers? I don't know. Is it all right? Are you?
I'm just still confused. Why isn't the derivative a line?
This is f prime.
Oh, that's a I did the same thing like 5 months ago.
You guys should hang out. Okay. So what else do you know? What about the origin? Are there other correct solutions you could draw for this? I don't know. What would they be? Johnny, do you want to say
I
something?
think theoretically there could be a hole at 0, and it would still have the same derivative function.
Oops.
Yeah, I know. So it would look the same in the derivative. So there could be a hole there.
It makes difference though, because the derivative is basically just the slope anyway, so it doesn't really take away the slope at 0.
Yeah, no, I said it could be both. I said it could
Yeah. We're saying both are right, and I think I agree with Johnny that this doesn't speak about that point right there. I mean, certainly for all values for which f is defined and has a derivative, this is a picture of that point, right? All right, listen, guys. Shh, go ahead, Ben.
Couldn't you technically move that up or down?
Which thing?
The one on the right, the actual function.
Yeah, could you? This is getting crazy, guys. Ben comes in strong. This is getting crazy. Ben suggests that this could be the graph too. What do you think?
Yeah.
It gets even crazier a little bit too. I have a little bit of an off-the-wall suggestion.
I'm already having too much trouble just keeping track.
Do you think it could look like this?
So I can't. No. Can we just
Right?
just say it's a normal one?
I think all of those are correct answers on this problem. Yeah, absolutely. Okay. All right. We're good. All right, I have a thing. Here's the thing. We're going to go over this in about 5 minutes, okay? We're going to do 5 minutes to work on this with your team. Well, check my slopes. Yeah. Let's be asking you, what's the slope of every action? So as you pick an X value, the question is at that point.
Okay, so people are like, I'm applying to 2 schools. I'm like, I'm just part of like 15.
Wait.
Yeah.
Perfect.
Mine is broken. It keeps hurting. I wore it out. I wore out the fabric because I love it so much. That work? That's not even on. How does that? It's fine. And I'm just gonna
Anywhere in the middle. Western Mississippi, before you hit like California and like the south, the very, very southwest. Like,